All right, so this is going to be a short video, kind of explaining, very basic video, kind of explaining what a neural network is. All right, so in this case, I'm gonna be explaining neural networks with recognizing written numbers, right? This is one of the use cases that can be applied to neural networks. Um, so these can be kind of trained to recognize poorly written numbers. Um, sometimes even humans can't decipher bad handwriting. So this is something that we can use neural networks to help us out. All right, so one of the main components here are neurons. Okay, so what is a neuron? I like to think of a neuron as a node that contains information about a specific parameter. It processes it, then passes it on to another neuron. So for our purpose, we can think of it as a circle that lights up based on its activation. In this case, we can see that if a number falls within a neuron, it lights up more than those that don't have as much ink on it. Right? And I'm saying ink because I'm imagining that somebody is writing on a piece of paper and then passing it on to this neural network. Okay, now in this picture you can see that somebody has drawn a 9. Now you can see that where there's more ink, I'm gonna keep using that for now. Um, where there's more ink or where it's brightest, you can see that the specific node has a larger value. In this case, around here, we're going to have a 1.0, right? This is the maximum. These nodes are between 0 and 1, the values. And so a 1.0 means that it is fully activated, and a 0.0 or 0.0 indicates that it is not activated at all. And obviously you can see that where the 9 is, there's a value between 0 and 1, and where it isn't is a 0 because, well, there's nothing on there. All right, so now I'm going to be talking about the layers, right? So we have our hidden layers, we have the last layer, we have our input layer here, which is the first one, okay? So now our hidden layers in our hidden layers are in between our first and our last layers. The activations of these nodes or these neurons in one layer determine the activations in the next through a specific algorithm or calculation that each node has to perform. Now our last layer, after the hidden layers do the calculations, the node in the last layer that is the brightest will be our final output value, in this case number 9. So now the goal of the hidden layers is to break down the number into little strokes. This can help the network match these strokes to numbers that have them, right? And the neural network determines that if this number requires these strokes, then it's probably that number. Now let me go ahead and explain a little more. Now we can see that we have our input, which is somebody wrote a 9 here, right? And we can just assume that this input is going to light up based on kind of like this, right? So each one of these nodes, we can say that it's each one of these. So now they're going to light up. They're going to have 1.0. They're going to have a 0.5, whatever is. That's what this is going to look like. Okay, so now this is going to pass on to this layer here. This layer here, we can say, and let's just say for this example that this layer is looking for little, like small chunks of it, little strokes. Now, it's kind of illustrated here in this number 9. Well, we can see that we have a pink stroke. We can see that we have a green one. We can see that we have a yellow one, an orange one, and so on. So now, let's say that this neuron here is looking for something that looks like this stroke here, a little horizontal line on the upper part of our space. So since this node here is seeing this stroke, this one is gonna light up. Now let's say this node here is looking for this green one. So now this one's gonna light up and so forth. Now here in this layer, this layer is gonna be looking for bigger strokes, broader strokes. Let's say, just for simplicity, that this first neuron in this layer is looking for a circle, a loop. As we can see in this one, it's looking for something like this. Now this one right here is going to learn through many iterations, where this is probably going to be in another video, through many iterations, this is going to learn that if it receives information from these nodes, let's say it knows that if it receives this stroke here, this one, and this one, there is probably a circle there. So let's say this green node, this one was looking for that green. I'm sorry, this green section. This neuron here was looking for this green section, so it's going to light up. The one looking for this yellow section is going to light up, I don't know, somewhere down here, and so forth. Now, this information is going to be passed on to this node. Now, this node is going to say, well, it looks like by the information that I'm receiving by these neurons, that there seems to be a circle here. So now this one's going to light up uh, uh, a little more than the rest of them. Now, let's say that this neuron here is looking for this line. Now, again, this one is going to learn, right, through many iterations, that if I see a yellow stroke here, if I see a gray stroke or brown, whatever color this is, stroke here, and if I see this kind of yellow stroke here, oh, sorry, I'm probably gonna have a line, right? So now this one is gonna receive all the information about a line, and now this one's gonna light up. So now we have the neuron that lit up because it thinks it sees a circle, and we have the neuron that lights up because it thinks it sees a line. And now here in our output, the number 9 here is gonna light up because the number 9 is saying, well, if I receive a circle and a line, there's probably a 9. So in this particular case, we're about 0.97 or about 97% sure that this particular number that I have received as an input is in fact a 9. Okay, so let's kind of summarize this one here, right? We get an input, certain nodes will fire. When these nodes get applied some algorithm, it causes nodes in the second layer to fire. And then again, with an output applied to these, other nodes will fire in the next, and so on until we get to the output layer. All right, now, but how can we tell? How can we tell that there is some stroke in an area? Okay, so let's just take in, for example, that one of these nodes, let's say this first one, right, just for simplicity. So it's going to take all of these activation values from this one here, right? And these activation values are being taken, for example, like this. Each one of these nodes are one of these initial nodes here, and they all have their values, right? Between 0 and 1 in this case. So these are going to pass this node and this node and every other node, their activation values, every single one of them. But then we also need weights, okay? So we need dial or knob-like parameters that we can tweak to light up or dim down a specific pixel. Or these parameters represent the brightness of the pixel in this case. So we will call these parameters weights. Each of these weights will be multiplied by an activation value. All of these will be summed up, and then, this can help us detect if a specific area is being activated and by roughly how much. Right? How significant is this area to our output? All right, now let's take this one for example. Let's take this picture for example. Now, let's say that, for example, this node here is in charge of detecting whether there is something in this area here, highlighted in green. Okay, so now each one of these right here is going to have its activation values, right? Because that's what this is for, right? Some of them have 0.0, some of them have a number between 0 and 1. So now they're going to have their activation values, but we also need their weights, like we said. So these weights are just numbers, and these numbers are going to be multiplied by the activation values. Now we're going to sum up all of these numbers, and we're going to get, again, some number. It can be either a really big number or a really small number. Now, this number here is going to be a number either really big or really small, like I just said, but we want our number to be between 0 and 1. How are we going to do this? We're going to use a sigmoid function. Essentially, what a sigmoid function is it's a function that is bounded between 0 and 1 in the y-axis. So you input a number, you input x, any number, and you're either going to get a number really close to 0 or really close to 1 or anything in between. Now, at the end of the day, what the summation of all of the weights times the sums This value is going to tell us how important this number is to our output. Is there anything there? Are we detecting any stroke there in this particular case? I don't know. Maybe we'll get a like maybe 66%, right? 70%. I'm just saying because it looks like 2/3 of the green area is filled out. Just a guess. But let's say that this green area was down here. We'd probably get something really close to zero. Okay. Now, like I said, this number is going to tell us whether or not this node here is going to light up, this particular node, because it's interested in seeing if there's anything there. So if there is, it's gonna light up, and if there isn't, it's not going to light up. And then it's gonna pass the information, and similarly, these will do the same processes. Every single node is gonna do the same thing. It's gonna pass this information. This one's gonna do another one. It's gonna pass the information, and so on. Okay, so in conclusion, neural networks consist of layers of neurons that transform input data through weights and activations. Each neuron in a layer connects through neurons in the next layer, allowing the network to learn complex patterns through multiple layers of transformations. Finally, neural networks power many real-world applications, including image recognition, language processing, and autonomous systems.